Hello, welcome to our second video about polar coordinates. This one is all about converting polar points. We're going to actually discover some rules and properties that are going to make life a little bit easier on us. So when we convert a polar point, we are converting it to a rectangular. Or we could be going the opposite. We could be taking the rectangular point and then turning it into a polar point. So for example, this first one says convert 3, negative 3 root 3 into a polar point, meaning that I want my r and my theta, because that's how polar points work. So a lot of times I feel like it's easiest if I draw a little picture, and this picture doesn't have to be perfect. We're just trying to get a visual of the situation. So I have 3, that's usually pretty easy to draw, positive 3, and then negative 3 root 3. So we're looking like somewhere right here-ish. So we want to find an r and a theta, which means I want the angle with the x-axis. And then I want to know the radius of the circle I'm on. Again, sometimes people like to think of r as the ring that you're on. So let's kind of connect this point to the center. So this would represent my r, and this would represent my theta. Now we're going to flash back to when we talked about unit circle, because we can turn this into a right triangle. So this is 3, and this is root 3. And then you have all the information you need to figure out your missing side. Now, some of you might already notice this as a 30, 60, 90 triangle, but just in case you didn't, and you didn't recognize your proportions, you would do your Pythagorean theorem to figure out your r. So we have 9 plus 9 times 3 equals r squared. Let's see, 9 times 3 is 27. Plus 9, so that makes 36. So that means r is going to be 6. Now, yes, technically, when you square root both sides, you should include plus or minus. And remember, you can express this radius in a positive form or a negative form. It just depends on how you like to do things. But for my purposes right now, I'm going to keep it positive. So that gives me my r. Now I need my theta. And again, if you didn't recognize that this was a 30, 60, 90 triangle, you could always do trig. You can always do your tangent ratio, because this is your opposite side and your adjacent side. And we actually just found the hypotenuse, so we could do any of the trig functions, but I like to stick with the sides that I'm given. So the tangent of my angle would have to equal root 3 over 3, your opposite side, over your adjacent side. And yes, I know that root 3 over 3 is negative. I realize that. But whenever I'm just doing an inverse tangent, I don't want to use the negatives. I want to figure out what my reference angle is, and then determine positive or negative by looking at my picture. And again, this is a 30, 60, 90 triangle. So when you pop that in your calculator, you're going to end up with 60. Let's make a note right here. So then I know this angle in my picture is 60 degrees. I know my radius is 6, so this point is the point 6, and then negative 60. Again, because I'm rotating clockwise. And again, there's a lot of different ways that you could express this angle, which is, again, is why I always just like to find the reference angle. Let's do it again. But before we do that, let's look at what we figured out, because these are some general things that you probably want to add into your notes. Here we use the Pythagorean theorem, right? And this was the x value this was your x squared plus y squared equals r squared. And that's always going to be true, no matter what. And then the other thing that we use that might come in handy is we did your tangent of theta equaled your y over your x. Great. So if we wanted, we could almost cheat a little bit and use these two rules. I have convert 0, negative 5 into a polar point. Again, this is a rectangular point, so it's an x and a y. So if I wanted, I could say 0 squared plus 5 squared equals r squared. Keeping in mind that when you square a negative, it becomes positive. This is 25 equals r squared, so r equals 5. Now I could figure out my angle, and some of you might already realize what it is. So I have the tangent of theta has to equal y over x, so y 5 over 0, which is undefined. The tangent of theta is undefined. So now you have to remember your special angles if you're going to do this. Which angle gives you an undefined tangent value? It's either a 90 or a 270, because that's where the sine is 0. Remember this bad boy? And so since this is negative, it's probably the 270. So you could say the point 5 and 270. Now, if you drew a picture, honestly, this one might have been a little bit more obvious. If you're rectangular, your xy is the point 1, 2, 3, 4, 5 right here. Well, then you're obviously going to have to end up being on your fifth ring because you're vertical. And then if you start here and rotate all the way around, it's 270. But it's nice to know multiple ways to do the same problem. So now let's go the opposite direction. This one says convert this into a rectangular point. So right now we are in the r theta situation, and we want to end up with the xy. And for our first example, let's go ahead and we'll just draw a picture. It'll be a rough picture, but it'll be a picture nonetheless, because I didn't print a polar plane here. So -2, so I'm starting this way, and then I'm rotating pi over 3. And pi over 3, remember, is 60 degrees in radian, or pi over 3 is 60 degrees. So I'm rotating positive, but I'm starting on this negative number. So we're going to say I'm about right here. So I'm on the second circle. My radius of my circle is 2. And the theta here is 60. So if you're good at guessing, you should realize that we are going to make a right triangle. Now, a common misconception is that this radius would be 2 on the x-axis as well. But make sure that you realize that this is the radius of a circle. So as you rotate away from that x-axis, that measurement is going to seem like it ends up being, I guess, longer. But 2, as it rotates away, is going to make a smaller measurement here and a longer measurement here. So this x-axis number is not 2. We're going to have to do some kind of trigonometry to figure it out. Again, we do have a 30, 60, 90 triangle. So we can always use that. But if it's not a special angle, we have to use trig. So I'm going to use trig right now just to kind of help you develop the rules. So if I'm going to figure out what y is, I would set up a trig ratio. I would say the sine of 60 equals opposite over hypotenuse, so y over 2. And then technically I would multiply both sides by the sine of 60, by 2, and end up here. The sine of 60 is root 3 over 2. So that means that this is 2 times root 3 over 2, which is just root 3. And I'm negative because I'm in the third quadrant. So if I have my x, I would say the cosine of 60 equals x over 2. And then I would multiply both sides by 2. And we all know that the cosine of 60 is a half. So we have 2 times a half. And you could punch this in your calculator. Now, so my rectangular coordinate point would be -1. And actually we have kind of developed a formula or a pattern. Notice that we have this and we have this. And you can always draw a picture. But when we get into converting whole equations, it's kind of nice to have formulas. So you can find your x value by taking your radius, which in our case was 2, and multiplying it by your cosine of your angle. And then you can find your y value by taking your radius and multiplying it by the sine of your angle. So this would be something to really add into your notes. It's pretty important. And for our next example, let's go ahead and use this. Now, when we do this, when we're using the formula without drawing a picture, I encourage you to use the negative numbers. So plug in your negative angle measures, plug in your negative R values, because that's going to get you in the right quadrant. So convert 3 -90 into a rectangular point. So my x value would have to be r times the cosine of theta. So my r is 3, and then the cosine of -90, which I can pop into my calculator. I can also do this in my head. And then my y value is 3 times the sine of -90. Again, if you choose to put in your calculator, make sure that you're in degree mode. If you're choosing not to do it in your calculator, negative 90 is down here. So your x is going to equal 3 times the cosine of 90, which is 0. And then it's going to equal 3 times the cosine of negative 90, which is negative 1. So it's the point 3 comma, or sorry. It's the point your x is 0 and your y is negative 3. Once you know your formulas and you get comfortable using them, they are actually a lot easier. So go ahead and make sure you have this written down in your notes. That's going to come in handy later, and these written down in your notes as well. And again, if you have any questions, feel free to email me. Make good choices.